Chalo. So we will start now. So in the previous class, I think we have covered the design of Jackwell. Okay. Now the only part which is remaining is the foundation and the column. Okay. So जहाँ तक अपना हो गया था. So fine. Okay. So now we'll continue with the old topic and we will see the design of columns. Okay. Now, if you remember in the pump house, we have not designed the columns. Okay. And remember the top ring beam was supported by 6 number of columns. Okay. So that time, if you remember, we have assumed the width of the support, that is the width of the column, as 230 mm. So I am continuing with the 230 mm. Only thing is the depth of the column. This I have to assume. So in this case, I am assuming the depth of the column as 300 mm. Okay. Now there are 6 number of columns. This configuration we have also seen in the earlier classes, and these columns has to be designed for the horizontal loading as well as the axial loading. Okay. So now what we are going to do is, first of all, we know how much the pump house base shear is. The pump house base shear can be calculated by a simple expression, that is Q equals to alpha H into W. Okay. So this alpha H value, can someone tell me what is alpha H value? Sorry, 0.06, isn't it? So let me note down. So this alpha H value, this value is 0.06 multiplied by weight. Okay. So this is nothing but the weight of the total pump house. Also here, if you remember, we have calculated the weight of the pump house W as the weight of roof slab plus weight of brick wall. Okay. These are the preliminary things which we have considered, and the value of this W was 769.63. Okay. So this 769, so this will be 769.63, and how much is this? I think we have already calculated this as 46.2, isn't it? So this is 46.2 kilonewton. So this is the horizontal force. Okay. Now the this is actually the pump house base shear. Now the horizontal force on each column, it can be calculated by simple expression 2 into Q divided by number of columns. Okay. So here all we can do is something like 2 into 46.2 divided by n, where n is your number of column, that is 6. How much is this? Someone please do the calculations. Yes. Sorry? 15 point. Okay. So this is the horizontal force which will be acting on each column. Okay. So now the bending moment has to be calculated. So this is the horizontal force which will be acting on a column. So what we are assuming, that this force is acting at the center of the column. Okay. So if you remember, the height of the column was 6 meters. So if you multiply this with 3, 3 is nothing but h by 2. So this value is nothing but 15. So this is 15.4 into h by 3, it's 6 by 3. Okay, how much is this? Sorry, kilonewton meter. Okay, so this is the bending moment which is occurring in the column, right? Now as far as the load is concerned, okay, so column is basically designed for the actual load. So this column load will be the total load divided by the number of column. Okay, so weight of the pump house we have already calculated. So this weight of the pump house कितना था ये, इसमें हम लोग पूरा कैलकुलेट करेंगे. ओके, सो दिस इज द सेल्फ वेट. Okay, so here if you see the self weight, you have the weight of the roof slab. No, sorry. We have to consider the same one because floor slab and all, it won't be contributing towards the actual load. Okay, so we have to consider only this part, that is 769.63. Okay, so this weight of the pump house, this will be same value, that is 769.63 divided by 6. How much is this? कितना आ रहा है? 1.27 kilonewton. Okay, so now basically we have to design a column, each column which is having an actual load of 128.27 and the bending moment of 46.2. Okay, so this is a typical RCC design. Okay, so I'll be a little bit fast. So here we have already assumed the depth of the column as 300 mm. The effective depth we can say it is if you see the effective cover of 50 mm, so we can have the effective depth as 250 mm. And accordingly if you want to calculate the reinforcement which is in bending, okay, so bending moment if you see it is 46.2. so this value is 46.2, sigma st is 130, your d is 250, and j value, what was the j value? Sorry, huh? 0.86. Okay, let me write down. So how much AST is required? One six 1653 millimeter square. Okay, and how about AST minimum? For column it is 1%. Okay, 1% of the cross section area, that is 250 into 300, कितना है? 230. 1% of the cross section area. Okay, 230 कैसे आया? वही तो मैं बोलूं. B is your 230 into depth is 300. इसका 1%. Oh, sorry, my mistake. तो ये कितना है? 690. Okay, so this value is wrong. This is 690. Okay, so definitely we have to consider this value because this is the largest one. So I suppose if you provide 20 bars, sorry, 6 bars of 20 mm diameter, it will contribute to 1885 millimeter square. So this configuration we can continue in the column. So if you go for this, we have to provide the nominal stirrups also. Okay, so we can design the nominal stirrups as per the codal provisions. Now all we have to do is just go for check for stresses. Okay, so first of all let us check the actual compressive stress in the column. So actual compressive stress in the column is area of the concrete. Okay, first of all calculate the equivalent area. So area of the concrete is 230 by 300. So this m value कितना है? Yes, m value कितना है? सबसे पहले कैलकुलेट किया था हम लोगों ने, ये वाले में नहीं है। चलो जल्दी बताओ एम वैल्यू कितना है? 10.98. Okay. Give me the equivalent area of the section, that is area of the concrete plus equivalent area of the steel. Yes. Yes, equivalent area of the section. Just a moment. 9,160. Is it correct? Someone please cross check. Okay. So the direct stress you can calculate, that is P divided by area. Your P value is 128.27. This is in kilonewton. Okay. So we have to make it to newtons, and this will be, the area will be in mm square. So this is 98160.95. How much is the direct stress? Sorry? 1 point? No, exact बताओ. 1.306. So you see this is slightly greater than sigma cc. Okay, sigma cc is directly permissible stress in concrete in direct compression. Okay, slightly greater than this one. Okay, so this is in newtons per mm square. Okay, now let us take the bending stress also. So bending stress is m by I into y. Okay, so the bending moment value is already known to you. We have already calculated the bending moment value, that is 46.2 kilonewton meter. Okay, so this is 46.2 into 10 to the power 6. Okay, right? Y is the distance of farthest fiber, isn't it, from the neutral axis. So this y value is going to be nothing but 300 divided by 2. So this is 150 mm. As far as I is concerned, that is I is the moment of inertia about the smaller axis, which is shown as a vertical line in the figure. Okay, so here the I value will be bd cube by 12. Okay, this is the moment of inertia of a concrete. But when it comes to the moment of inertia of the steel, so moment of inertia of the steel is nothing but ast into d1 square, that is area into distance square. So d1 is nothing but your 100, because you have an effective cover of 50 mm, and the distance of the one edge to the neutral axis is 150 mm. Okay, so the d1 value will be your 100 mm. Okay, but this is steel, so we have to convert it into equivalent concrete. For this purpose we have to multiply this with 1.5 m minus 1. Okay, so this is going to give you the equivalent moment of inertia of a section, which is contribution of concrete as well as steel. Okay, now this ast has to be taken from both sides. Okay, क्योंकि 3 बार तुम्हारे यहाँ पर है, 3 बार तुम्हारे उधर भी है. Okay, so you already know the value of ast provided, that is 1885. Okay, So this value is 1885. D1 value is 100. M value, I think it is 10.98. Okay. Your B value is 230 and your capital D is 300. Okay. So just let me know the value of I. बताओ. Yes, anyone I value? डेसिमल्स मध्ये सांग ना. 80. हाँ. हाँ. 6 millimeter to the power 4. Okay. So how much is the bending stress now? So this I value you have calculated over here. How much is the bending stress? 8 point. This is Newton per mm square. Okay. So now all we have to do is check for the combined effect. So sigma cc actual. Okay. So sigma cc actual you have just now calculated as 1.306 at the end. Okay. So this is 1. अच्छा, this is not sigma ct. This is sigma cc. Okay, fine. Sigma cc is कितना आ रहा है? 8.56. How much is this value? Definitely it should be less than 1.33, so you don't have to worry. कितना आ रहा है? Sorry? 1.22. Okay. So 1.22 is less than 1.33. So our column is same. Okay. What I skipped over here is the design of stirrups. Okay. So as per IS 456, whatever is the procedure, please follow and give the appropriate design for stirrups. Okay. Uh, yes, online students, is it everything fine? Any
Yes,
query?
sir.
Yes.
Okay, now I am able to hear you properly. Fine. Good. So we will continue now. Now the last part remaining, this is the foundation part. Okay. So just please pay attention on the figure. So you see our Jackwell is having the innermost clear radius. Okay, radius is 3 meters. Okay, diameter is 6 meters, and we have already provided the thickness of this Jackwell as 230 mm, right? So the outer radius of Jackwell comes out to be 3.23 meters, right? Now for Jackwell, we have to design a footing, and this footing is called as a annular footing. Okay. So the basic definition of annular footing is the projection which you are seeing on the inner side as well as on the outer side. So the inner side projection is more and outer side projection is less. Okay. So here in this figure you can see there is a PO and there is a PI. PI is the projection which is coming on the inner side of the Jackwell, and PO, it is the projection which is coming outside the Jackwell. So annular footing is is a footing where the inner side projection is more, outside side projection is less. Okay. So now with this, now we have to go for the design. Okay. So the now very first thing is what is the total vertical load. So when I say total vertical load, this means every load. Okay. And this every load we have already calculated in form of a self weight. Okay. So this self weight is A plus B plus C plus D plus E plus F. This we have already calculated, right? And in that we have added some vertical load also. Okay. So the additional load we have already calculated. It is something like half of this, that is 68.45. This is the vertical load and the original load is 2285. ठीक है, तो हम लोगों को इन दोनों को ऐड करना पड़ेगा. ठीक है. So I think we have done some addition over here at the end, that is 2281.66 plus 68.45. So the total vertical load P is coming out to be 2350.11. ठीक है. So this includes everything. Okay. So 2350.11. So let me note down. So this value is 2350.11. This is kilonewton. Okay. I hope this is clear to everybody. Now coming to the area of the footing which is required. Any queries? ज़्यादा क्यों है? वो एडजस्ट करने के लिए है, वो टॉपल नहीं होता. नहीं तो अंदर वाला प्रोजेक्शन ज़्यादा रहा ना तो टॉपल नहीं होता. दैट इज अ टिपिकल फुटिंग विच इज कॉल्ड एज एन्युलर फुटिंग एंड मोस्टली इट इज प्रोवाइडेड फॉर द वॉल. ठीक है. एनीवे, so we need to find out what is the area of the foundation which is required. So what we usually do, it is we assume the 10% of the load of the total load as a self weight of the structure, and then we divide it by SBC. So the total load will be increased by 10% just to take care of the self weight. So this will be 2350.11 into 1.1, and in the problem the SBC is given to you as 100. Okay. So how much is the area of the footing which is required? Someone please tell me the calculations. 28.5 मीटर स्क्वायर. समवन प्लीज क्रॉस चेक. बराबर है. ठीक है. So basically we need to have a cross section or the footing area which is at measuring about 25.85 meters square. Okay. Now here we have to do some trial and error kind of a stuff. Okay. Now here in the case of annular footing, there are two things which you need to follow. The first one, the area. The area, whatever width and dimensions you are assuming, it should give you the appropriate area. Okay, so required area is 54.85. So the area calculation of the foundation is very simple. You just have to calculate the area which is coming outside minus the area of the inside. So if you refer this particular figure, so this is your central axis. Okay. So from here to here, this is your R outer. Okay. And here to here, this is your R inner. So pi R outer square minus pi R inner square is going to give you the area of the foundation. Okay. So whatever value you choose of R outer and R inner, with that whatever area you are getting, it should be greater than the required area, which is 25.85. Otherwise your foundation is going to settle. Okay. This is first criteria. The second criteria is the radius. Okay. So here radius is R. So this effective R can be calculated by 2 by 3 into R outer to the power 3 minus R inner to the power 3 divided by r outer square minus r inner square. So this r value should be as close as possible to r1. Okay, when I say r1, this value is nothing but your r1. ठीक है, आइडियली दिस आर, ये जो रेडियस है आ गया, दिस रेडियस इट शुड फॉल इन बिटवीन दिस, यहां पर आर आर आना चाहिए, ठीक है, एंड इट शुड बी एज क्लोज टू द आर आउटर. So this is the one of the criteria, right? Now with this assumption, now we have to adjust the r outer and r inner. Okay, now first of all we need to define what will be the width of the uh, foundation. Okay, so width of the foundation can be calculated by simple expression, that is the area whatever is required divided by the circumference. Okay, so here I am taking r1. Okay, r1 value is your 3.23. Okay, so with this how much is the width required, can someone tell me? Yes, please. So if you take this width and if you go for a circle, so you are going to get a simple plane. कितना है approximate width? 1 point, okay, 1.274. So approximately this value, this should be 1.274 approximately. Okay, so now we have only one solution. We have to go for some trial and error method. Okay, so just everybody please pay attention on the screen, don't write anything, just try and understand this what is happening. Okay, so I am going for trial 1. Okay, so for trial 1, I am assuming the R outer as 3.8, okay, and R inner as 2.5. Okay, R outer is 3.8, R inner is 2.5. So very first thing I need to choose whether the outward projection and inward projection, whether it is satisfying the criteria that inner projection should be greater. So if you calculate the outward projection, so outward projection will be how much? R outer minus 3.23. Barabar? This is nothing but your outward projection. It is coming out to be 0.57. Okay, and if you calculate the inward projection, it is nothing but 3 minus R inner, that is 2.5. So the inner projection is coming out to be 0.5. तो यहाँ पर क्या हुआ, आउटवर्ड प्रोजेक्शन जो है वो ज्यादा है और इनवर्ड प्रोजेक्शन जो है वो है कम. सो दिस इज नॉट सेटिस्फाइंग दिस क्राइटेरिया, तो ये कॉम्बिनेशन तुम्हारा स्क्रैप हो गया. ओके, it is also not satisfying the criteria, that is the required area is 25.85. okay, so area required is 25.85, whereas if you see this is lesser than that, so this is also not satisfying. So this trial is completely gone wrong. ठीक है, let us go for some different trial. So in the second trial I am taking the outward projection as 3.8 and inward projection as 2.4. so inward projection मैंने थोड़ा सा अंदर कर दिया. okay, so now if you use this combination, so the outward projection is 0.57 and inward projection is now 0.6. so as far as this criteria is concerned, this is satisfying. Okay, and if you see the area, so area is coming out to be 27.2, जबकि चाहिए कितना 25, तो ये बहुत ज्यादा हो गया है ना. दिस इज ऑन हायर साइड. एज वेल एज इफ यू सी द आर वैल्यू हम लोग कैसे निकालेंगे, यूजिंग दिस एक्सप्रेशन. okay, and this value should be as close as possible to r1, that is 3.23. so the r value, it is coming between 3 and 3.23, so this is okay, and it is slightly towards the outer side, so this is also okay. It should not, the r value should not cross the wall, Getting it? So this looks okay, the second trial looks okay, but the issue is the area which we are providing, it is 2 meter square higher, जबकि चाहिए 25.85 and you are providing 27.27 roughly. So this need to be revised, right? So accordingly now you have to just keep on changing some projections, some inner radius, outer radius, everything. So at the end, let us say I have gone for so many cycles, so in sometimes this is failing, okay, the area is not sufficient, okay, sometimes this area is sufficient, okay. So you can see this 8 trial, okay. So 8 trial is going to give me a value of 26.4, and this value is 3.14. ठीक है. So I have gone ahead, and at the end I am settling at this, okay. So here you can see I have taken the r outer, r inner. So inner projection is 0.57, outer projection is 0.56. So this criteria is also satisfied. The area which is required is 26.5, and whereas your actual area required is 25.8. So 25.8 and 26.5, so roughly 0.7 मीटर स्क्वायर एरिया अपना ज्यादा है इसमें, ठीक है. एंड इफ यू सी द वैल्यू ऑफ आर, इट इज ऑल्सो very close to, or rather it is in between the wall, that is 3 and 3.23, it is exactly in between. So if you want you can go for more trials, it will take some time. So for the time being we'll stick to this one and we'll go with the further design, okay. In examination you have to keep on trial, dimensions नहीं दिए रहेंगे, okay. The load will be given but you have to go for trial. पहले छोटा करके देखो, फिर बड़ा करके देखो, अकॉर्डिंगली यू हैव टू एडजस्ट, ओके. सो लेट अस फिक्स दिस 11th trial. So after 11th trial you will find all the dimensions are written in the figure. So R1 value is 3.23. The innermost radius of the Jackwell is 3, and the outermost radius of the foundation, that is R2. Okay. So here you can see this is your R2. So R2 is 3.79, which here R outer is mentioned over here. The projections are also mentioned over here. I think I have not mentioned the R inner. So R inner is 2.43. So from here to here, 2.43 meter. Is it okay? Okay, so using this trial and error, you have to finalize the dimensions of the footing, annular footing. Okay, तो ये समझ में आया. ये वाला टेबल लिखो, 2-4 ट्रायल लिखो, तुम्हारे काम में आएगा, ठीक है. सीरियस
सर एग्जाम में हम सेकंड इसमें रुक सकते हैं ना?
रुक सकते हो, बट यू हैव टू ऑप्टिमाइज एंड यू हैव टू स्टॉप ओनली व्हेन ऑल द क्राइटेरियाज आर सेटिस्फाइड.
सर तो सेकंड वाला ट्रायल में अगर सेटिस्फाइड हो रहा है तो हमें ज्यादा एग्जाम में करने की जरूरत नहीं है.
नहीं नहीं चलेगा, कोई प्रॉब्लम नहीं, ठीक है.
सर
प्लीज नोट डाउन एटलीस्ट कपल ऑफ ट्रायल्स. Are there any queries? Meanwhile, just please answer your attendance, okay? Yes, roll number 1 is there online. Okay. Online students roll number 4, 8, 14 and 18. Okay, so that is
Yes, sir.
4, 8, 14 and 18. Okay, roll number 2 is here. Okay, 3, 4, 4 is absent, 6,
No, sir, present.
4. Okay, okay,
Yes, sir.
that's okay. 7, 8 is online, 9 is absent, 10, 11, 12, 13, 14 is online, 15, 16, Shashwat, 17. Yes. Shall I change the slide? Just write couple of slides only, couple of trials only. It is just for your understanding. Yes. Shall I continue? Fine. So after all this calculations, now you are ending up with these dimensions. Okay. So now very first thing you need to calculate is the upward pressure intensity. How much upward pressure intensity is there? So for this we need W. So W is the total weight. So the total weight, I think we have calculated this as 2350. Okay, 2350.11 into 10% of that, 10% as a foundation self weight. Okay, so this is 2350. So let me note down over here, 2350 into 1.1 divided by, now r outer square minus r inner square, pi. This should be less than your SBC. बराबर है? So this r outer is something like 73.79 and R inner is 2.43. How much is the upward pressure intensity? Yes, anybody? That is 97 point, this is kilonewton per meter square. Okay, so if you remember our SBC of soil was 100. Okay, so we have provided slightly higher size or the per meter square area, that is 0.7 से हमने ज़्यादा दिया हुआ है ना? So that's why you are getting 97. It is less than SBC, so this is okay, right? So now we have to now calculate the shear force. Okay, so the shear force has to be calculated on the surface. Okay, so the shear force, maximum shear force which will be caused due to the upward pressure intensity, it can be calculated by a simple expression P divided by 2 times R1. Okay, what is your R1? R1 is this one. Okay, this is your R1. Okay, and then R2 square minus R1 square, right? So you know the values. So this P value is just now we have calculated, that is 97.27. This R1 value is 3.23. Okay, R2 value it is 3.79 and R1 is 3.23. Yes, how much is the shear force? कितना आ रहा है shear force? 191.2. Someone please cross check. This is the shear force which is coming at the section, outer section. 59.19 kilonewton. Okay, so this is the shear force. Okay, so now since this is the footing, we have to calculate the bending moment which is there due to the upward pressure intensity. Now this is an annular footing, slightly different than the our regular footings. So for the annular footing, the bending moment has to be calculated using the expression something like this. So where the p value is 97.27. Okay, R1 value you already know, this is 3.23, and R2 values are also known to you. So directly give me the value of bending moment. कितना आ रहा बेंडिंग मोमेंट? एनीवन? बोलो. Sorry? 70 point 17 point. Okay, काफी कम है. This is kilonewton meter. Okay, so now all we have to do is do the depth calculation. Okay, so for working stress method, bending moment is nothing but the moment of resistance, which is equals to QBD square. So their bending moment value is, just now we have calculated, that is 17.01 into 10 to the power 3. Your B value will be 1000. What will be your Q value? 1.527. Okay, give me the value of D then. Sorry, this is 17.07 into 10 to the power 6, not 3. कितना आ रहा डेप्थ? 106. बहुत कम है. Okay, and in the foundation we generally go for clear cover of 50 mm. Okay, so this is 106 plus 50 mm, so it becomes something like 156. Okay, so this becomes 156 mm. Okay, so I think we can go for 200. Okay, so what we will do, we can finalize this capital D as 200 mm, and your this small d. So small d, we can deduct 50 mm, so this becomes 150 mm. ठीक है? So, since it is kind of a isolated footing, so the depth will be continuously reducing towards the free end. Okay. So, what we can do is we can have depth something like this. So, at this level, okay. So, at this level, you can have the total depth of 200 mm, and at this level, you can have the total depth of 150 mm. This is sufficient. Okay, so now we have to go for the calculation of AST, and the standard equation for AST is bending moment divided by sigma st into J into T. Okay, so sorry, just do the calculations. The bending moment value you have already calculated as 17.07 10 to the power 6. So this is 17.07 10 to the power 6. This is 130. This is 0.86 J, है ना? 0.86, and D value will be 150. That is 200 minus the cover. How much is the AST? 10. Okay, and this AST outer and AST inner, that is a distribution steel, it is 0.24% of the cross section area. Now here the cross section area, in this you have the outward projection. So outward projection and inward projections, they are slightly different. So outer is 0.56 and inner is 0.57. So this is 0.57 and this is 0.56. This D is still 150. This is 150. This is in meters, so you can write this as 560, and here you can write this as 570. Okay. How much is the steel? प्रॉफिट क्लास मध्ये आहे, नंतर बोलतो मी. कितना आ रहा है? कम आएगा ये. बोलो भाई कितना है? Outer inner distribution steel, कुठला? 201, and inner is slightly more, 205. Okay, so it is not that much. Okay, so you have to draw a appropriate figure. You can see a perfect figure is drawn over there. You have to provide the main reinforcement. Okay, so main reinforcement, it will be there in terms of horizontal bars. Okay, so these bars, it should be having sufficient spacing so that the equivalent steel should be greater than 1014 mm square. Okay, so for this, can you tell me what will be the spacing for 12 mm dia bars? 12 का बार के लिए स्पेसिंग कितना आएगा? Yes, sorry, 110. 1 तो 110 है, so we can go for 100. ठीक है. So the horizontal bars, okay, the one which is shown in solid line at the bottom, so this has to be provided 12 mm dia bars at 100 mm center to center. Okay, and the dots, these are nothing but the distribution reinforcement. So minimum AST is something like 201 and another is 205. So for this purpose you can have 8 dia bars at how much will be the spacing, बहुत ज़्यादा आएगा इसका spacing, कितना आएगा 205 के लिए स्पेसिंग कितना है 8 डाया बार्स का, 240 है ना. So we cannot provide because the depth of the footing itself is 200. Okay, so just to ensure safety you can provide 150 or we can even provide 175 mm center to center. ठीक है, these are the distribution steel. ठीक है, 250 is not recommended, even 200 is also not recommended, we can go for 175. Okay, so this completes the entire design. So we have covered pump house, we have covered Jackwell, we have also covered the foundation. Okay, so I think this is all from my side for today. Okay, are there any queries? Yes, yes, are there any queries?